Hello everyone, this is Mrs. Lindsay, and today we're going to talk about increasing and decreasing functions. So first we're going to take a look at a graph, and we're going to talk about increasing and decreasing behavior. So if we take a look at this graph, how would you classify, what would you look at to think about or talk about what would be increasing and what would be decreasing? If you need to, please go ahead and pause and kind of think about that. And then when you're done, push play and we can discuss it and go over a few different things. Okay, so if it's increasing, hopefully you're kind of looking along these lines here. You're taking a look and saying these are increasing. So what's going on at those different points in time in your graph? And what is occurring is that your slope is positive. And if you look at the reverse for decreasing, these are the areas that it's decreasing, and here your slope is negative. Okay, so where do we think about slope? And hopefully you're thinking about derivatives. But here's some other examples. But one thing I want to kind of point out here, I'm going to highlight a couple different points here on here. The first ones were marked with yellow and pink, and all of them were consistent. What do you think's going on at those points right there? And if we draw a tangent line at those points, what kind of tangent lines are all of those? Well, they are horizontal lines. And what do we know about horizontal lines? Slopes is 0. So those are kind of some critical points that are definitely going to help us with our derivatives and when we're actually figuring out increasing and decreasing intervals. So, for example, if you take this first graph over here on the left here, it is actually decreasing until it gets to this critical point. And then it's increasing until it gets to that critical point, and then it's decreasing. So those are definitely some critical points that we need to figure out to help us with our increasing and decreasing intervals. All right, so let's again think about derivatives and slope here. A function is increasing when the derivative would be what? Well, a derivative gives a slope at an instantaneous point along the graph, so in other words, at a single point. Okay, so in this case, when our derivative is going to be greater than 0, so in other words, positive, and it's going to be decreasing when the derivative is less than 0, so in other words, it's going to be negative. Alright, so let's keep going here. Alright, so what do we see on the graph of f of x when the derivative is 0? And again, we really already talked about this just a little bit here. If you take a look here, what is going on at those points right there? Well, again, you have horizontal tangent lines. So these are horizontal tangent lines right here. So again, we're going to have a slope equals 0. So this is definitely a key point and one that we need to make sure that we understand there. Okay. What could be true on the graph of f of x if there are places where the derivative is undefined? So where would that occur? It could be in a graph, what you're looking at right here. So if I drew something kind of like this, right? So what would happen there? Well, a critical number, in this case, we would have the derivative would equal 0 or the derivative is undefined. So again, this would be a place that we would have something, a critical number that we would need to address when we're talking about our increasing and decreasing intervals. So let's actually go ahead and try an example here. And please feel free to pause anytime that you need to with these and push play again or rewind and watch them again or re-listen to. And again, please jot down any questions that you would like to ask in class or feel free to email me as well. So here we have an example. Find the critical numbers and open intervals on which the function is increasing or decreasing. And we pointed out something earlier. Again, we know, what do we know about the derivative? With these critical numbers, we know that the derivative, oops, let me erase that. The derivative is going to be 0 at these critical points because we have horizontal lines there. So let's first take the derivative of our function here. So we'll have 2x minus 8. And because we know the derivative again is going to be 0, we're going to take that derivative of 2x minus 8 and we're going to set it equal to 0, and when we solve for x, we will get our x values of our critical numbers. So we'll add over that 8 and divide. So we know that at an x value, now we don't know the y value right now, but we know at our x value here that we will have a horizontal tangent line, and that's going to be one of our critical numbers. Okay, so now we just need to figure out what's it doing on the left-hand side of this, to the left of it, and to the right of it. So we're going to draw a number line. So here's 4. And we're going to figure out, okay, what's going on at these values below it. So -3, -2, and then what's going on at the values above it, 5, 6, etc. as we go to infinity in both directions. Okay, so I'm going to pick a value somewhere to the left of 4, because this is going to be our critical number. So our critical number is 4. So let's pick something less than 4. Let's pick something that's easy. Let's pick 0. 0 is less than 4. And we're going to plug that into our derivative here. So if I plug in 0 for our derivative, 2 times 0 minus 8, we get a -8. And it doesn't honestly matter if it's -7, -8, whatever. We just care that it's negative. That's going to tell us what's going on there. And this is going to tell us that it's decreasing until it gets to the critical value of 4. So now we're going to do the same process to the right, or to the numbers above 4. So I'm again pick a number that's above 4. It doesn't matter which one it is. In this case, I'll just go ahead and pick 5, and I will plug that in. So if I plug in 5 into my derivative, you get 2 times 5 minus 8. So we'll get 10 minus 8, which is 2. And again, we don't really care what exact value it is. We just care that 2 is going to be positive. So this is going to tell us that the function is increasing after 4 is to the values greater than 4. So again, if we're doing our increasing and decreasing intervals, increasing interval starts at 4, and it goes to the right or above 4, so it goes to positive infinity. We're going to use parentheses on both of those. And it's decreasing from negative infinity, so everything to the left or below 4, up to my critical value of 4. And hopefully this makes sense, because if you graph the original function, I'm just going to put a brief sketch of it up on the side here. It is a parabola. It's x squared, and it's opening the leading coefficient's positive, so it's opening up. We know the critical value is at 4, so I know somewhere over here at 4, I have a parabola. So again, this is going to be at the value of 4 right there, where I have my critical value. It's going to be decreasing everywhere below 4, so it's going down. Oops, my arrow's going the wrong way there. So it's going to be decreasing everything up to 4, so it's going down this way, and then once it gets to 4, then we have everything increasing. And that is what all this process over here to the right is describing. So let's go ahead and try another example. So in this case, the same exact directions. We're going to look for the critical numbers, and then we're going to determine where the open intervals are for where the function is increasing or decreasing. So the first thing that we're going to do is take the derivative. So derivative of g of x. So we're going to do low d high. So low is x squared. Derivative of the high. So we'll have 4x cubed minus high d low. So 2x over low squared. Okay. Now, before we didn't necessarily always simplify these. In this case, we're definitely going to want to help us figure out what these critical values are. So I'm going to simplify a little bit. I'm going to go ahead and multiply here, get 4x to the 5th. and then distribute through. And please remember we have a negative here, so that has to distribute through as well as the 2x. So that would be 2x to the 5th minus 2x over x to the 4th. And then we're going to keep simplifying here, so combine like terms. 2x to the 5th minus 2x over x to the 4th. And one last step that we're going to do here is we can factor out and cancel an x out of all of those terms. So we'd have 2x to the 4th minus 2 over x cubed. So next we're actually going to now find our critical numbers, and there's going to be a little bit different approach that we do with this. So with our critical numbers, I'm just going to use that as Cn. First we'd take the entire derivative, just like we did in the previous problem, and set that equal to 0. And we'll go ahead and solve that one. But I do want to point out one little shortcut here. To get rid of x cubed, we'd multiply both sides by x cubed. So we would take this and multiply by x cubed and x cubed, but every time we do this, when we have a fraction there, it's going to cancel not only on this right hand side, but it's going to be 0 on that left hand side as well, because we're setting equal to 0. So some of you might just say, you know what, I need to just take the numerator and set equal to 0, and that's absolutely fine to think of it that way. And then you're just going to simply factor, set each one equal to 0 there. There's a couple different ways to do this one. You could do dots, difference of two squares if you prefer, or again you could just set it equal to 0 and then take the 4th root of both sides. So in this case x would equal plus or minus 1. But there's another portion that we can't forget about here, is because we have some undefined values because we cannot divide by 0. So whenever we're working with our fractions here and we have a variable in the denominator, we also have to set our denominator equal to 0 to find those undefined values whenever we're finding our critical numbers. So we set the entire thing equal to 0 and as well as our denominator. But in this case, when we take the cube root of both sides, you're going to see, in this case, that cancels off and x equals 0. So now we have 3 critical numbers of 0 and plus or minus 1. So we still are going to do the exact same process. Now where is it increasing or decreasing? Let me expand this just a little bit so I have a little more room. So I'm going to make it a little bit larger number line, put it in order, -1 to 0 to 1. Now we have several different intervals that we need to check. And we're going to just plug in some random values into our derivative. Very key. I'm going to put -2 in because that's below -1. Something in between 0 and -1. Something in between, sorry, that did not write very well. Let me erase that. Something in between 0 and 1 here, again into our derivative, so I'll do just 0.5 in this case, and then something above 1. So go ahead and take a minute, please pause the video, plug those into your derivative. Again, really, really important. You can use your calculator, that is fine. Plug it into not your original function, your derivative. So I would suggest using the simplified version right over here. So we're going to plug it into this portion right there. So go ahead and pause and find those values. Okay, so I got these values here, -4.5, 15, -15, and 3.5. But what's really important is whether or not, again, it's positive or negative, because this tells us which intervals are increasing or decreasing. So in this case, we have it is decreasing. We'll just start with the first one here, from -infinity up to our critical value of -1. Then it's decreasing again, so you can use a comma or you're welcome to use a union there. I'll use union in the next case, between 0 and 1. Then it's increasing from -1 to 0, right here. And I'll use a union in this case, as well as from 1 to infinity. So this actually concludes the first section of increasing and decreasing in chapter 3 for increasing and decreasing intervals in our functions.